So, welcome to another episode of CAD Mondays. If you haven't yet, subscribe to the channel. Like the video if you enjoy it, comment below. Do the whole YouTube thing. Today, I am going to show you how to import a file from an online library, as well as how to program a bomber seat. So, let's get at it. What we've got here is a model that I pulled from online. It's a racing seat model that I grabbed. Super accurate. Somebody modeled this thing beautifully. I throw it into the odd model here and there to check fitment on stuff. I know it's dimensionally accurate, close enough for my own purposes. This is the site that I tend to get most of my models from. GrabCAD is awesome. If you go up to community, click library. In order to download anything, you've actually got to set up an account. But just to show you here, in theory, if we were looking for, say, an Optima battery, something we all recognize, we can type Optima battery into the search bar, and it'll bring up associated files with that in the name. So click a random file. Somebody's actually taken the time to even put stickers on this thing. Super nice model. Basically, all we're looking for in the menu here is files which we can open. In my case, I can open quite a few files. I can open SolidWorks files. I can open anything AutoCAD Rhino. This is actually the model that I just had on my screen. It shows you the previews. The file selection there will show you the files. Once you find a file that you like, it's as simple as clicking the red download button that's at the top, saving it to your computer, importing it in. Sometimes you got to mess with some files. I can show you all that on a different day. But for our purposes today, let's use this. If I'm skipping anything, I'm sorry. There's a whole lot of information in this video, and I'm trying to cram it together. Basically, the reason I brought this in is because it's a known good seat model. It's something that most people can fit in, so it's something I can pull dimensions from. I know that everybody's a different size, but I wanted to build a seat just for the sake of argument that was reasonable to what most people would sit in. And I mean, pulling the measurements, it looks kind of like we should be able to do an 18-inch square base. Some people don't realize that seats are generally reclined about 10 inches, and this one is no different. This one reclines, but a fixed seat is generally going to be reclined about 10 inches from perpendicular, from 90 degrees, so 100 degrees base to back. That's not uncommon at all. We know that we want about an 18 by 18 inch square here. And I know that I want to build a low back, so I want something that comes below the shoulder strap area there, kind of, marking on the area there. So we know that we want this seat to be in the neighborhood of about 20 inches tall is where I feel this seat's going to be comfortable. So for this file, I'm actually going to work with a lot of solid commands versus lines that I normally do. Normally I'm extruding lines. This one, I'm working with a lot of solids. So we grab the solid box tool, 18 by 18 inches, 20 inches tall, and that gives us our three-dimensional block. Now, we know that this block wasn't square because it's reclined 10 degrees, so we can turn on the edit points, rotate those points 10 degrees back, and that gives us our reclined shape. That's the back of the seat versus the base of the seat. That is the area that we need. Now, we also know that it was only about 10 inches across at the back, and I wanted that measurement because I wanted the back of this seat to be rounded. I wanted the back and sides to be one piece. And this seat's actually going to be designed for hard rivets. Whether or not this is the actual seat that I build, I've still got to refine my design a little bit. But this is going to be similar to what ends up in the car. So I can go up into my solid tools and use the fillet tool, and I select 4 inches because 18-inch width, 4 inch per side gives us 10 inches left over in the middle, which is what I was shooting for to begin with. Now we've got our rounded shape. And Now it's just a matter of, if you picture when you're a kid with your first buck knife whittling away the edges to reveal a sculpture within the log, that's basically what we're doing here. Excuse my artistic expression for a moment. But this is where my line tools come in, because I can actually draw line shapes. In this case, I want the front lower corner of the seat to kick up. It gives a place for the cushion to sit into. You slam on the brakes, you don't slide forward off the seat. So all I'm doing is building a triangle that mimics the shape that I want and moving my control points to where I think that incline looks correct. Once I've got that correct, I can select my lines, use the extrude in a straight line tool, and we use the solid difference. I'm going to use that a lot today. Solid difference is so handy when you're doing this kind of thing, because I can grab my original shape. It'll say grab the second shape, grab that, I can delete the input, and what I'm left with is the piece with the negative space removed. We're going to keep using this tool. It's going to be used quite a bit. I also, when I mount seats in the vehicle, I tend to recline them so that 10 degrees back to base, I tend to recline seats around 10 degrees, means the back is reclined about 20 degrees from ground level. And I moved the model back because I wanted the lower portion of the side bolster level to the ground. So all I'm doing here is using my line tool again. I know that I wanted the top corner at your shoulder, at your armpit, essentially. I wanted that beyond the curve. And you can see the curve tools. That's why I've changed this from a shaded view to a polyline view. I'm using the fillet tool from the line selection. Radius is in the corners here. Once I'm done, I need to project this to C-plane, delete the input, and extrude in a straight line. This is all stuff that you'll see over and over again in my videos when I'm doing things. So play the video back. If you watch up top, it'll actually give you the commands that I'm using. If there's something I've missed, please let me know, and I'll try to break it down. I'll respond in a comment, or I can do a short video, or we'll figure something out. I can show you the way. I know I wanted my side bolsters rounded at the front, not the pointed lines, so all I did was grab the solid edit tools, the fillet tool. I radius the front edge, and now we have what looks like the outer skin of a seat. A lot of this process isn't going to make sense right now, but once we get everything done, it will. Now, down on the bottom where I was just circling, I know that I want a seat belt hole. So all I'm doing is grabbing my rectangle tool with the rounded corners, pick some dimensions that sound about right. Like 4x2 sounded about right here, with a not fully rounded corner, a little bit squared off. I'm just rotating it. There was no science here. This was literally just, this is kind of what I felt looked right and where I decided it should end up. This may change down the road as well. Once I've got it moved and I'm happy with it, we go right back to the extrude command, extrude this. I've got the multiple views open because I can select the piece and I can see my extrusion. That extrusion needs to go all the way through the piece we're working on, or else this doesn't work how we need it to work. Once again, use the solid difference tool, and it removes that seatbelt pocket for us so that it punches through both sides. I'm still trying to figure out my mic hooked up to the computer, and then once that's done, I can actually explain all this as I'm working, and maybe these videos will be a little bit better. Right now, I'm working on it. I know I want these seats to be dimple dyed as well as bead rolled, so what I'm doing here is I'm just using my cylinder tool. I want them in line with the seat, so I'm rotating it to the seat back. Pretty simple command. I just grab it on the corner that I want to spin it, set my angle, rotate it. I just drag it down 2 inches. Again, this is all by eyeball. This is all by feel. These dimensions could be different for whatever dimple die you were using. I may change it. I may use different sizes. I may do varying sizes. I'm not sure, but I want to hammer this through this video as fast as I can here and show how it all works. I can copy from the center each direction, use the differences command from the solid edit window again, and remove those. And as I was looking at it, I realized that I probably want some dimples lower as well. So I'm just Control Z and I can undo it. And all I'm going to do is I'm going to copy those 3 spots. From that, I'm going to copy them lower into the back and punch a couple more holes in the back here, just for more dimple dies, a little more strength, a little more style. I want this to be strong. I want it to hold me tight, but I also want it to look good, obviously. I'm not planning a ton of padding on these. They're just going to be super simple, riveted together. Basically, these seats are only going to be 2 pieces of metal off the plasma table, and then metal worked and riveted together, and that's it. I like to double check my work, look at it from different angles. The front's going to look weird right now because those pieces are punching through. Now, I want some dimples in the side as well. Those side bolsters are fairly high to keep me contained, so just using the same cylinder tool again, copy a couple of cylinders. You know, this is all stuff that is happening over and over again. Yeah, the video is happening faster than I can explain it. Some of this stuff I'm just on autopilot and it happens super quick. So I've got my side holes punched in it. Now I have my mostly assembled. This is what my seat will look like, with some obvious pieces removed so we fit. I've been making sure to save my progress, and I save it quite a bit because I can always go back. If I'm not sure about something, I'll actually copy the piece off to the side. In this case, I'm copying the piece because we're going to need to use this form twice, and I'll come back to that a little later in the video, but I have files where I will have pieces copied 6, 8, 10 times so that I can see different progresses and change things along the way. Now, one of the advantages of the CNC table is that I can punch my dimple die holes, I can punch shapes, my seatbelt holes, I can punch just about anything. In this case, I'm going to mark all of my solid rivet holes. And part of the reason that I copied this over to the other side is that I don't want the solid rivet holes in my base. I only want it in my outer structure because metal does not work exactly like it does on the computer. Not the way I'm using it, so it's nice to have a little bit of room for error. All I'm doing here is just copying this piece, or copying these soon-to-be holes in a pattern that's kind of pleasing. I went through and measured the distance off of there, make sure that my holes end up, on the distance I want. Of all the weird coincidences, by the time I copied these down, it somehow lined up with the bottom rail as well. I'll be honest, that was dumb luck. I wasn't expecting that bottom hole to line up. But now I can just copy this bottom hole and just copy it along the bottom the same as I did on the upstroke. I've got, these are going to be 3/16 solid hard rivets. I'm spacing them 1.25 inches apart on the side here. I don't know if it's overkill. I've never actually messed with solid rivets myself, so this will be experience. Here, I'm just mirroring my rivets to the other side. As long as the line's perpendicular, I can save a few steps. I was going to mirror them again here because I got ahead of myself, and then I realized that it wouldn't go perpendicular. And as I looked at the model with the other windows open, I realized that the last rivet is actually past my curve. Now, I'm building this with straight bends. I'm not flanging on the curve. So the sides and the back will only be attached on the sides and the back. The curved section is just going to float. That area is going to be supported by a different gusset later, which I don't show in the video, but it'll just be a simple bent piece that'll rivet to the bottom and the back to triangulate that back corner. I just don't get to it here because honestly the video ends up pushing it a little bit. So I'm going to the back, and I obviously need rivets in the back as well. So it's the same command. I'm going to grab these cylinders and the exact same 3/16 rivets. Now, since I'm only cutting through the back, these don't need to be very long, and we obviously don't want them to blow through the bottom here. So I'm not making them super long. I just want them to poke through so that I can use it for my differences command. Rotate the rivet so that it's in line. The only reason I'm doing this is because if I were not to put it in line, it would try to cut these holes a little bit ovaled. I may change these to pierce points down the road and actually just have pierce markings instead of actual holes. But for our purposes, the holes demonstrate a little bit better. When I produce the cut file to go out to the table, I can actually just go in and change them all to pierce points and do away with the circles. It means a little bit more work because I'll have to drill them all out, but it's aluminum, and honestly, it'll only take about 2 minutes on the seat to punch 3/16 holes through all of them. What I'm looking at here is I'm running into the same thing. When I had them spaced 1.25 inches, the rivet was on the line for the bend. Now, I already know that my flange won't be there, so I'm trying to space out rivets to where they don't end up on the bend. And I'm just trying a few different spacings. I end up spacing these 1.125 inches apart, I believe. It's weird voiceovering because the little screen on my phone here is too small for me to see my actual measurements. You'll know, and I don't at the moment. But once I've got them all figured, I grab the ones on the side. I can mirror them to the other side. Saves me copying. Use the solid edit difference tool again, and that'll remove all of those rivet holes as well. Now we've got all those rivets punched in there. Now, other than the bead rolling, this shell is exactly what I want. Now, obviously, I could model bead rolling. Realistically, I just don't see the point in it. Maybe for a visual thing if I was going for an extensive model, but the reality is that I'm going to lay it all out with a Sharpie and do it myself. Now, from the solid, all I did was grab the explode tool. Now, the cool thing is that with the explode, it actually breaks this down to individual surfaces. With the individual surfaces, I can go through and I can remove every surface that I don't need. That's the inside of the holes. Now, every time we punch a hole in there, it ends up with another surface. All I'm doing is going through and removing every surface that we don't need. That's every rivet hole, every dimple hole, everything there. Now, one of the coolest commands here is it's actually an unroll feature. Oh, I missed a piece on the front there I had to go back for. So I can actually take all of this and I can develop a file that I can cut straight from this 3D model, which doesn't help most people because most people don't have the software, don't have the time or the capability to program it, and don't have access to the tooling. But if I join all of those surfaces together, which are now one plane, there's no thickness to what's on your screen. Picture a piece of paper. I can actually unroll it. The command is unroll surface, and it looks like I actually missed one tiny piece on the top there that was connecting them. Once I go back, we can re-explode it, and you can see that third dimensional piece. It would have been the top lip. I guess I missed that, but I can go through, select it, select everything, deselect the base because that won't be part of it, join the rest, and I'm going to unroll it again. And what I end up with, random spot on my screen and random rotation, is actually an unrolled picture of what we were just building. Now, this is a super cool command because trying to build these with line tools, it's pretty much impossible. It gives me the advantage that I can work with curved shapes and still, as long as it's on one plane. If it was a complex curve, a sphere, it would not unroll this shape. It would give me an error. But because there is only one bend in that plane on each side, it's all working in one plane, the bends are in one dimension, I can actually just unroll it. So now, since I've just got that shell, what I'm going to do is I'm going to drag it back over top of my second model. Now my second model is going to become my base. The reason I'm dragging it over is because I need flanges. I'm drawing a line along the bottom here so that I can offset it 1.25 inches. That's how high the flange will be. The flange will be bent up on the inside, and then the rivets will pass through the side, through my base plate. All of that will be hidden by a cushion on the inside. On the outside, all you're going to see is a nice brushed or polished face with nice aluminum rivets there, and it's just going to look clean. The placement of my rivets there, I didn't want to delete that one rivet. I probably could have, but I didn't feel like it. But I do need my flanges to not touch. It could literally be 1/10,000th of an inch. It doesn't really matter to the software, but for the commands that I'm using, I can't have them touching. So I go in and I use my trim tool, remove the lines in the middle, and the points look kind of funny. So I'm going to go in and radius these, use the fillet tool, and I'm going to radius these. The first time I hit it, the radius was too large and it just fails to do it. And then visually, it just, you got to go by eye here and see what actually looks right. You don't want to do a fillet that looks ridiculous. But again, these are all spots that are going to be hidden from the eye anyways. Now what I'm doing here is I'm building a line structure that I can build another solid off of, just as I did to shape this seat. And I'm going to use the solid to remove the material. Basically, we're mimicking what we just did on the seat back and sides. And I'm using the back and sides as the overlay because that means my flanges here, I already know that my flanges are going to work for my rivet holes. I've got meat around them because I'm literally staring at it in 3 dimensions here. So I know that they're going to fit. I'm drawing the line tool, project it to C-plane. Everything's joined, and I'm going to extrude it straight. And once again, on the top view, you can see I pull that straight through. All I care is that it comes all the way through. Use the solid difference tool, and we're going to remove that portion. Now, I can delete my line tool. It looks a little bit off right now because I've still got the seat back on top of the seat base. So I've got 2 solids taking up space here. So all I'm going to do is move it out of the way. I usually use round numbers, move it 50 back, 50 over. That gets me out of the room in the front view or the back view, the side view, whatever. That means it's not in line on the straight on views that I'm using. And you can see where my flanges stick up there. Now thinking back to the other seat, how I removed everything, just take a moment, you can envision how once I remove, or once I explode this, it's going to leave me with flanges. But I obviously need to do the same thing to the back now as well. Now on the back, we know the rivets don't come past the bend, so I can just draw a simple line. I can round it over. All I'm doing is bringing it up 1.25 inches, over 10 inches, because that was the width of our straight section, back down 1.25 inches. And then I'll draw a random shape out beyond this. I'm converting this back to a polyline view because then I can see it because the line was hidden within the solid. And I'm literally just, there is no logic to this line I am drawing. I'm just drawing it outside so that it removes material. The beauty of having multiple views is I can zoom in on different views and get the points, and I know in the 3-dimensional view that I'm actually attached to the point I need to be at. but I need to turn this because I need that 1.25 inches along the back. So I'm going to grab my line, use my rotate. Oh, actually, my bad. I needed to radius these corners first. And now I'm going to use my rotate command and rotate it from vertical. I don't need to punch in numbers. I can just drag it to the angle of the back. Use my extrusion tool, solid extrude in a straight line, and it extrudes it straight along that plane. And we're back to the solid difference tool. All I'm doing is dragging it through here. It usually removes, but I found that every once in a while it gives a file where if I haven't dragged it past the edge of the solid, it does a weird thing. So habit that I tend to remove it. But once the top's cut apart, there's nothing holding it to the bottom, and I can actually just remove it. And now with it like this, I can actually explode it. I have my flanges here. This is similar to what I had in the back. When I'm working with solids, I like the shaded view. It's just easier to work on because I don't have to grab individual lines. And obviously this looks pretty weird at the moment, but I can explode it. And I started grabbing individual shapes, and then I realized that there's a whole lot of individual shapes in there. So instead of that, I'm just going to grab the outer faces of my flange, the two side flanges that fold up, the pieces that make up the base, the back flange, the other two sides, and I'm going to join all of those together. All you do is type join once they're selected, hit enter, and they become one piece. And now I can select everything, deselect, holding shift or control, holding control, deselect that, and it gives me my base piece. And if we grab that base piece and we do the surface unroll tool, same as we did on the back piece, what we're given, and let me zoom out and I can zoom back in here, is our flange, the way that it is supposed to look. Now that is the piece completely broken down. Now obviously these are just surfaces. There's no polylines here. It's just a plain surface, and that doesn't help the plasma cutter at all. So, oh, what have I done? Oh, I know what I've done. Since these are surfaces, there's no thickness to them. Now my flanges are going to bend up from the edge of that material. So I know that if I'm building this out of 1/8 inch for the sake of argument, that I need to bring these in 1/8 inch for this material to come in. Now if these were just dimple dyed, we could make them out of 1/8. Bead rolled, we're probably going to make them out of 16 gauge. So what I did is I turned on my my edit tools here, and I turned on my control points and I slid them in 1/8 inch, giving myself that gap. Now realistically, if I use 16 gauge and these are in 1/8 inch, it's not the end of the world. The seat will pull in that much, but I'd rather have it pulled in a little bit for the sake of argument. The flange doesn't get bent up perfectly, or we're going to bend these by hand. That 1/8 inch gives me a little bit of wiggle room. You can see it there. And the outer skin, the back and the sides, the material will be on the outside of that, so it doesn't affect the fitment to the flange at all. But this means that even if I messed up bending the flanges a little bit, I've got a little bit of wiggle room so that I can drill my holes. We'll drill one at a time, put a cleco in them, and eventually hard rivets, and we're good to go. What I'm doing here is, since you can't see drop-down menus, I actually go through and I saved the file, and then I exported this seat as file name bomber seat for rat rod. I'll show you that in a minute. And then I redid the surface unroll, or the unroll surface command here. Now, if we go into our curve edits, there's a command in curve edits that is duplicate edges from surfaces, and it'll say select your edges, and we can actually select all of the edges here, hit enter, And then we can go back in and delete our surface and go back in and delete our lines. These lines would have been the beginning and end of our roll, essentially. We're going to do the same thing on this one and duplicate them, delete our surface, and go back in, and we can delete all of the cross lines here. Now, some of these would be bend lines. If we need the bend lines there, these ones all get bent on points, so it's not a big deal. But if we needed the bend lines there, what we can actually do is just grab the point tool, and if you leave a point on that line, say 2 along your bend mark, redelete the line, and there's those 2 points there. Those points are the points that you need centered on your press brake to make it all work. You could put them there, you could put them in the middle of the piece, anywhere you need it bent. The back is a roll, so not quite so simple. But the back roll we could actually do basically on the seat, because we could rivet the back section and roll it around the seat. The material will be thin enough. So if you see my previous videos, this is the frame that I built, showing you how to model a mandrel bent appearing frame. And I can actually import the seat that I just built. And all I did was import the file, drag it in. It's built in the same dimensions. It's in inches, not metric. So as you can see, it fits. If I go to the side view, you can see here that I'm just dragging it into place to where it looks right. Drag it up until it's above the frame. You know, the seat back is kind of level with the door opening. That sounds about right. That's kind of where it's going to be comfortable, because, you know, the window opening is about where my arm will rest, which means the seat kind of comes to my armpit. That's what I had envisioned in my head. Now, the beauty of the CAD software here is that the door bar I had drawn in earlier, we can quite obviously see that the door bar I had drawn is not going to clear my seat. And that's what the seat basically at the center there. I'm trying to move it around a little bit and make it work. But you can see when I mirror the seat there, they were overlapping. So undo that, drag it off to the side a little bit, and I can re-mirror it. Now, the thing to remember in this model is that what I'm doing right here doesn't really apply, because I have a drive shaft that's going to come through about 8 inches above my floor, so those seats can't touch. However, the bar that I had drawn in there is dropping on the frame, which is a few inches in from my actual door. I should have room to slide these seats out about 3 inches either way, and then I can build my door bars around it, as opposed to what you can see here. But that's 2 seats sitting on top of a frame that I built. I love doing this stuff because it gives me some visual cues. I can look at the space. I know that if I move these out 3 inches, I can get my drive shaft through. My tunnel will be tight, but I know it'll fit. On the underside here, I'm planning some ribbed braces, kind of where the cursor's going there. And I may actually mount them with tabs kind of from the side, like modern racing buckets use. I haven't quite determined that, but that would be a really easy addition to the file. And I know this video dragged on, but that's where we're going to leave it off today. I hope you gained some knowledge from this video. If you did, give me a like. Share the video around, subscribe to the channel. I really want to see this thing grow. I want to be able to put the time into videos. Give me a subscribe, like the video, comment below, give me some feedback, do the YouTube thing, and I will see you on the next one.